For years, additive manufacturing has carried a promise. Not just complex parts, not just challenging materials, not just responsive lead times, but also production. A different mode of production, highly automated, digitally based. At Incodema 3D in Freeville, New York, that future is here. It's the present.
Today, we're operating right around 50 metal additive machines and about 40 CNC machines in that space. We see the business growing very rapidly, adding 10 to 12 printers annually. We just did an order for 15 additional printers that are actually arriving right now. Growth is very rapid today.
One of the largest additive manufacturing operations in North America, in the world. What did it take for Incodema 3D to get to this point? What does scale production additive manufacturing look like? And what does the company's success say about the state of additive manufacturing today? Hang on, here's a look at Incodema 3D. Describe to me the company's founding in terms of what you were thinking at the time and how you first realized the promise of additive manufacturing as you're experiencing it now.
I started using additive manufacturing back in the late 80s, and it was primarily in the plastic arena. I brought metal additive manufacturing into Incodema in 2012 to build tooling for our precision sheet metal company. Didn't take long to recognize it was a good fit for that, but even a better fit for some of the aerospace applications that our customers were demanding. So we made a decision to say, let's roll this out as a separate entity, being very focused on the defense and energy sectors.
Initially with just 2 additive machines, the company moved into this 60,000 square foot facility in 2015. The ongoing production today is in nickel-based alloys, titanium, aluminum alloys for applications in industrial, energy, defense. In the past decade, many companies have bought metal additive machines. Fewer have transitioned them into production assets, and fewer still have scaled out, multiplying the number of their production additive machines. Persistence and patience were part of the ingredients for Incodema 3D's success. And in addition to that, on this journey, they weren't alone. Your major customers, many of them, had roughly the same laser powder bed fusion capability that Incodema 3D has. Would you talk about why that fact has helped with what has in some cases been a very long learning journey?
We're on the same platform, so we're speaking the same language. They have their parameter sets, they bring us the parameter sets, we work on applying that to a production plan, and they come to us for that experience. They come to us for our experience in producing the part to their specification. They have seen it from the beginning as not being a prototype. They saw this as a path to supply chain production. They're designing right from the beginning for function and designing right into actual production with this technology. We're essentially a digital foundry.
The development time could be a decade, and you're in production with parts now that have gone through that decade. What's happening during that time?
During those periods, that's when we actually were prototyping the parts that we're in production today. So it's real, it's taken that long. A lot of these parts go through rigorous testing. These are very, very important defense-oriented components where my customer told me one time, Sean, if there's a problem with this part, it probably means a US soldier will die. They're mission critical, they're super important, and they have to be right. So taking the time to make them right is super important to us and our customers. For years, Incodema 3D worked with companies on production that was still far in the future. Then multiple production programs reached maturity at the same time. So all of a sudden, production wasn't the promise, it was the day-to-day reality. How is product development different from production? And how did the company change as it moved from focus on one to focus on the other?
With product development, and really even more so with prototyping, you're really focused on how fast you can go and on figuring out what can be done. Whereas with production, what you really need to focus on is the discipline of doing the same thing over and over again. And what they want is reliability and repeatability. The most important thing is to be reliable, high quality, and on time.
Scaling production meant finding the right technology platform, buying more additive machines, and advancing the systems around those machines that support repeatable production.
Today we're exclusive to EOS because, one, their equipment works the best in our experience. They have the best service organization, they've stuck by us, they've supported us, and they've iterated very well with the technology. And at every advancement we've seen gains, right? Speed gains, ease of use gains. They've been a great partner.
On the additive side, when the machines are running, they're running unattended 24/7. We're able to incorporate the EOS dual exchange and some of the quick change in the exchangeable frames to make quick changes where instead of being down for hours or days between jobs, it's 30 minutes between jobs. Coming from a machining background, when you get a upgrade to a cutter or something and you get a 10% increase, everyone's excited. That's a big deal. When we went from the single laser machines to the quad laser machines, talking about a 400% output. That kind of leap in the technology is amazing, and it offers better throughput, offers us the ability to give customers more competitive pricing and keep up with the production ramp.
Much of this additive manufacturing is unattended, but a printed part is typically not a finished part. That's why at Incodema 3D, the additive manufacturing machines are matched by almost as many CNC machine tools. Because in the case of many additive parts, maybe even most of them, the hardest part of manufacturing comes after the printing.
The machining, you have to approach it in many different angles, many different setups. The tolerance really comes to fruition during the machining cycle. You have to have work holding printed into the parts. You have to design for that whole process. You have to have the team effort going into that.
The last year or two has been significant growth from us as a company and our customers as well. We've really seen from going to a small number of true production programs to rampant production. Allows us to just run our huge fleet of EOS machines at 80% utilization and just ship production parts to our customers. To know that you're shipping out hundreds and thousands of components a day is really unique within the last year or two, where that's an everyday occurrence rather than a milestone. We have over 100 programs that we would consider in production right now, and when we walk through our facility, there's just multiples and multiples of the same part.
The RFQs, the requests for quotes that are coming in from customers, they're coming in for much more mature additive parts. It's not just we see a part that says, hey, do you think you could print this casting drawing? Instead, we'll have a fully developed additive variant come across, ready to quote. And it's a lot quicker to get a new printer installed than to install, or build a whole new casting or forging house. Our ability to quickly scale, our ability to meet the economics really have come together over the last couple of years to open up significantly larger programs to additive technology.
For years, we've looked at additive manufacturing with an eye toward what it might become. At Incodema 3D, it has become that thing. Additive manufacturing is the foundation of a production system supporting over 100 ongoing programs, producing hundreds or thousands of components on any given day. Customers no longer come to the company to investigate whether additive manufacturing might do the job. They come because they've already designed the part with additive in mind. Rather than an emerging technology, this technology has emerged.
I think you have to make that commitment that you're going to stay true to that process, and knowing that the manufacturing process is going to ultimately slow things down versus coming out of a block of material which is proven and known. You're going down the unknowns because this hasn't been done in the past. It is a manufacturing revolution that is viable and being proven every day with new intricate components.